A warm welcome and greetings to my dear students and friends. Today I am going to deliver a lecture on the column, the case of strength of material. So what is a column? Column is a pure vertical member that carries load from the beam and the slab and it transfers to the wall footing or the foundation. And the foundation will transfer these loads to the earth below it, that is the soil below it. And what are the types of column? Column is mainly classified into short column and long column. What is called as a short column? Short column is defined as the ratio of the slenderness ratio, that is based on the slenderness ratio, the column is based on the short column and long column. What is called as slenderness ratio? Slenderness ratio is defined as the ratio of the effective length of the column to the least radius of gyration. So it is a ratio, so that is denoted by the notation lambda, and it is a unitless quantity. When lambda is less than 12, it is called as a short column. The short column will fail due to the crushing load or the compressive load failure. And in the case of a long column, that is when the slenderness ratio is greater than 12, it will mainly fail due to the buckling effect, that is called as the bending effect. The bending of the column, that is the buckling load, can be determined by the famous theory which is called as the Eulers theory for long column. The Eulers theory is mainly used for the long column analysis and the design of the long column. The Eulers theory will not hold good for the short column because the short column will fail due to the crushing load. It is not fail due to the buckling load. But in the case of the Eulers theory, the critical load can be determined by the assumption made in the Eulers theory. So what are the assumptions made in the Eulers theory for long column? The Young's modulus of the column should be the same for the entire length of the column. The cross section of the column is the same throughout the span or the height of the column. The cross section will not vary from section to section. And the Eulers theory is mainly used for predicting the buckling load of the long column. The buckling load can be determined by using the Eulers theory. In the case of a critical load for the long column, P suffix E, that is for the Eulers critical load, is equal to pi square into EI by capital L square, where capital L is the effective length of the column and E is the Young's modulus of the column material, and I is equal to the least moment of inertia of the column. It may be of a rectangular column, square column, or the circular column. So based on the shape of the column, you can definitely find the moment of inertia in the x-axis axis, that is Ixx, and also the moment of inertia in the y axis, that is Iyy. So whichever is a lesser quantity, you can take it from that Ixx and Iyy. The column normally will be of a rectangular, square, or circular in cross section. The case of Euler's theory of a long column, the slenderness ratio is always greater than 12 or equal to 12. So here the column will mainly fail due to the buckling effect or the bending effect, not due to the crushing load failure. So what about the crushing stress for the short column? So crushing stress or the failure stress is equal to the breaking load or the crushing load of the short column divided by area of cross section of the column. So it is measured in kilonewton per square meter or newton per square millimeter. So in the case of column, there are four different end conditions of the column. The first one is when both ends of the column are hinged, it is called as a hinged column. The second one, when one end is fixed and other end is free, it is called as a cantilever column. Third one is when both ends of the column are fixed firmly, it is called as a fixed column. And the fourth one is when one end of the column is fixed and the other end is hinged. For all these type of four columns, you have to find the effective length of the column, that is capital L, or you can put L, a small l suffix effective. But in the case of a hinged column, the actual length is equal to small l, effective length is L effective or capital L, that is equal to actual length itself, that is capital L is equal to the small l. But in the case of a cantilever column, the effective length capital L or L effective is equal to 2 times the actual length of the column, 2L. But in the case of both ends of the column are fixed, the effective length is equal to actual length by 2, actual length by 2. And the fourth one, when one end is fixed and the other end is hinged, means the effective length capital L is equal to the actual length divided by root 2. It is small l by root 2. In all these four type of column, which is the worst case? The worst condition of the end condition of the column are a cantilever column, because the critical load will be the less value it will take, but the fixed column will take the more load, so that is the having the high effective load carrying capacity. So you can design the column based on the required condition of the practical site. You can have these four different type of column. So normally it will be used for any structures which is of one end is fixed, other end is hinged, or one end is fixed and other end is free, means a cantilever column. For designing a cantilever column, you should be very careful in designing the critical load or a buckling load effect of the column. In addition to the Eulers theory, you can apply the Rankine's empirical formulae for the long column as well as the short column. So it holds good for the short column as well as the long column. And also the ISI method of the right column is also there, that can be also be used based on the given conditions. So you can use as the empirical formulae or the ISI code formulae, or if it is a long column, definitely you have to go for the Euler's critical theory to design the load or design the column section. In this video, uh, we have known about the types of column and what are the end condition of the column, how will you find the crippling load or the buckling load of the long column, how the short column will break due to the crushing load. These are the things I have seen in this video. Thank you very much for patient listening. Thank you and goodbye. வாழ்க வையகம், வாழ்க வளமுடன்.